So today we will talking about everything is visible first.
Yes.
Today we will talk about emerging and digital transformation technology, starting with artificial intelligence, VR, blockchain and cryptocurrency, Internet of Things, edge computing, Industry 4 and robotics. And now we will start with artificial intelligence. Artificial intelligence is the simulation of human intelligence processed by...
Sorry, your presentation is not in full screen mode, and it's not...
Are you sure?
Yeah.
Okay. We'll do it again. Is it okay now?
Yes, perfect.
Okay, thank you. So artificial intelligence is the simulation of human intelligence processed by machines, especially computer systems, and specific applications for artificial intelligence include expert system, natural language processing, speech recognition, and machine vision. In computer science, artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans and animals. Leading artificial intelligence textbooks define the field as the study of intelligent agents, any device that perceives its environment and takes actions that maximize its change and its chance of successfully achieving its goals. Cool. The term artificial intelligence is often used to describe machines or computers that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. Artificial intelligence as a service refers to off-the-shelf artificial intelligence tools that enable companies to implement and scale artificial intelligence techniques at a fraction of the cost of a full in-house artificial intelligence. The concept of everything as a service refers to any software that can be called upon across a network because it relies on cloud computing. Artificial intelligence as a service is an emergency artificial intelligence adoption model that has its roots in the general software as a service, or a SaaS wave of recent years. We talked about this yesterday. The software as a service model began to gain traction as industries across vertical began shifting towards the web as the primary application delivery mechanism, initially for external customer-facing use, but increasingly for internal enterprise delivery. Artificial intelligence as a service enables companies to implement customized AI solutions on the one hand with minimal investment and artificial intelligence domain expertise expertise on the other. As a service, vendors understand vertical industries and build sophisticated models to address their unique use cases with remarkable efficiency. These service solutions are cloud-based providers, are able to deliver them as a service that can be accessed, refined, and expanded in ways that were impossible in the past. We are passing through this point one really rapidly because the theme is really big, and when we finish the courses and when we do the final versions, probably there will be a little bit more extended information about artificial intelligence and the major point. But this here we mark this this part. Again, there is too vast to be delivered only in one point. So today we just mark the major points about the artificial intelligence. Virtual reality and augmented reality. Virtual reality is a computer-generated environment with scenes and objects that appear to be real, making the user feel they are immersed in their surroundings. Immersed, isn't it? Sorry. This environment is perceived through a device known as a virtual reality headsets or helmets. I think that most of you are already familiar with this headset or these helmets. Did someone try it? Augmented reality is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information, sometimes across multiple sensory modalities, including visual, auditory, haptic, somatosensory, and olfactory. I think that the last thing that I saw, the last product that I saw in augmented reality was swimming glasses that projects everything on the screen. So you can measure the distance in deep and so on. Augmented reality vs virtual reality. Augmented reality uses real-world settings, while virtual reality is completely virtual. Augmented reality users can control their presence in the real world. And the VR users are not controlled by the system, are controlled by the system. So when you're using VR, you stop to get information from the real world. You are just in virtual reality. Virtual reality requires a headset device, but augmented reality can be accessed with a smartphone. Augmented reality enhances both the virtual and real world, while virtual reality only enhances functional reality. The third point is blockchain and cryptocurrency, and today I will be a little bit more I will do like how to say it, we will get deeper into this theme. So, how the thing starts, and actually what happens when we're talking about human history. During all the human history, humanity always solves different problems, and usually this comes with newly discovered technologies. First, in the mid-15th century, the printing press made it possible of knowledge to become accessible to a much larger number of people and to be just as elite. So, in this case, the printing press solves the problem with the education and spread the knowledge through not only for elites but for the whole masses, and this pushed the development of the humanity much faster. In 1720, Thomas Newcomer invented the atmospheric engine. It was used to drain water from mines, replacing horses. The Scotsman Watt improved the design, but by raising the efficiency, and the steam engine give the necessary boost in the early starts of the Industrial Revolution and at the beginning of the 18th century. In Britain, in the 90s, the horsepower became much more, and so they invented and they came with a new type of engines, and that gives a lot of more horsepowers to the machines, and the problem was solved. And in practice, 500 horses was replaced by one pump from an engine. At the end of the 19th century, the internet solved the problem of distance. Large volumes of information can be freely and affordably sent and received. Technology became widespread. So this, you see, the humanity in different stages and different ages decide different problems. First was with the education, the second was with the horsepower and the power. The third one is solving the problem with the distance. And at the end, with blockchain technologies, we solve the problem of trust in the internet. How the thing started. So we can continue with the topic. I will give you a little history of the development of this blockchain technology. In 1991, originally, the concept of which blockchain technology is based was created by two scientists, Haber and Stroneta, if I pronounce it right, in the Journal of Cryptology. It was supposed to propose a system that creates a stamp on digital documentation, so that it is not possible to change the date and its content. On type to perform the function of the notary, but in the end, this technology remains unused. And this continues in that way till 2008. On 18th of August in 2008, the internet domain Bitcoin.org is registered. On the 31st of October in 2008, Satoshi Nakamoto, I think that everyone was heard about this person, published a scientific work entitled Bitcoin, a peer-to-peer electronic cash system, was uploaded to the site. It detailed the method of using peer-to-peer into the web and explained it as a trust-based electronic transaction system. For those who are interested, you can later I can share it to this article. It's only 9 pages long, but it's the foundation of something that the whole world has been trumpeting lately, and it could possibly play an integral role in human development. To insert peer-to-peer means when in a computer network, each computer is like a server for the others, allowing access and sharing of the files of the other computers without the need for a central server. As torrents, for example, or uTorrents, or you can give a lot of examples in that. In January 2009, the Bitcoin network is launched, and the first block is mined by Satoshi, giving himself a reward of 50 Bitcoins. Each first block of a blockchain is called Genesis block. Then, little by little, more people, perhaps out of curiosity, download a program with which they mine, receive, and send Bitcoins, and slowly begin to exchange. This cryptocurrency, which still has in that time, still has no value. In 2009, Nakamoto mined close to 1 million bitcoins before disappeared and passing the baton to another programmer. Then still the value of the transactions is determined by the people in the forum, with the most significant transaction being the purchases of 2 Papa John's pizzas, and in that time they pay for these 2 pizzas 10,000 bitcoins. You can imagine in today's world what this means. Probably the most expensive pizza ever. On the 6th of August in 2010, the only bug in the Bitcoin protocol system has been identified. Transactions were not properly validated before. Before entering the Bitcoin protocol transactions logs. After a few days, someone gives himself 186 billion coins. After a few hours, this is noticed and it is deleted. The system is updated, and this is the first and the last problem in the history of Bitcoin ever recorded. So at the beginning, there was a small problem. In 2011, other cryptocurrencies start to appear. Today, I think we cannot count it. In 2012, over 1,000 businesses start accepting Bitcoin as a form of payment. Today, there are much more. In 2013, Coinbase announces they sold 1 million of Bitcoins and roughly $22 per Bitcoin. And in 2018, to this day, it is pointless to talk about what happened. It is just show you. It is just important to mention that between 2013 and 2018, there was a transaction with Bitcoins, but the price was really low, and nobody give attention to that. At the end, in 2018, the Bitcoin start to rise, and in 2020, we know what was the price for one Bitcoin. The price rise so rapidly because a lot of people start to make transaction with a Bitcoin. But let's back to blockchain. Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems on the blockchain. And a little bit later, we will talk explain what is that digital ledger and distributed digital ledger. What actually is blockchain? As the name suggests, blockchain is a chain of blocks that contain information. We can also call it the trust machine. It's the same. There are three pieces of information on the block. We have data, we have hash, and we have hash on the previous block. By the data, we mean the information on the block. In this case, I will give you an example of what is contained as information in Bitcoin block. It contains information from who came the transaction, to whom. So Jenny sends to Johnny, let's say, 1,000 Bitcoins or 1 Bitcoin. And this is the information that we have in the block. A hash is like fingerprint, but digital fingerprint. It identifies the block and all its contents, and it's always unique. As a block is made, the hash is calculated, and when we created the block, the hash is calculated, and when something in the blocks change, the hash change. And this is the most important thing. The third element is in each block is the hash from the previous block, and this actually creates the chain of the blocks, and that's why this system is called blockchain. And because all the blocks are chained, we have this strong security. How does this work? If you have an example of 3 blocks, each block contains its own hash and the hash of the previous block. the first block does not point to any block because it is Genesis block. In case you touch something in the second block, its hash change immediately. Therefore, in the block 3 and all after it became invalid. But using hashes is not enough to prevent blocks from being fixed. Computers today are very fast and can calculate hundreds of thousands of hashes in 1 second, which means you can recalculate all the hashes for this block and the blocks ahead to get everything right with one cheat. For this reason, blockchain has a means to effectively combat with potential problem. And this potential problem, we solve it with proof of work. Technically, proof of work or work as follows. If we talk about Bitcoin, it is a digital currency that is supported by type of distributed ledger. For this distributed ledger, we will talk a little bit later. The ledger contains a record of all transactions arranged in consecutive blocks, so that no user can pay with the same money more than once. To prevent tampering, the book is public or shared. And if there is a modified version, this modified version will be soon rejected by other users. Blockchain technology is most simply defined as a decentralized distributed ledger that records the provenance of a digital asset. By inherent design, the data on a blockchain is unable to be modified, which I am explaining just now, which makes it a legitimate disruptor for industries like payments, cybersecurity, and healthcare. When we're talking about, and the next, we will talk about ledger and what actually is ledger. But let's make a small break for 10 minutes, I suppose. I suggest, actually. So after that, we will continue with the presentation. See you in 10 minutes. Hello again. We will continue our work. So before continuing with the ledger, I want to say a few more words about the blockchain. The way users detect the hack in practice is through hashes, long strings of numbers that serve as a proof of work on the block. Put a given set of data through a hash function. Usually for Bitcoin users, they use SHA-256, and it will only generate one hash because of the avalanche effect. However, even a small change to many parts of the original data will result in completely unrecognizable hash. Regardless of the size of the original data set, the hash generated by a given function will be the same length. Just generating a hash for a set of Bitcoin transactions would be elementary for modern computers. So to make the process work, the Bitcoin network sets a central level of difficulty. This setup makes it so that in order to get a new block and to add it to the blockchain after a valid hash has been generated. In time, it takes roughly over around 10 minutes. For example, one block contains 2012 transactions involving just over 1,000 Bitcoins, as well as the date of the previous block. If a user changes the transaction amount, even only with 0.00001 Bitcoin in his ledger, the result new hash would be unrecognizable, and the network would reject it as a fraud. Proof of work makes it extremely difficult to change any aspects of a block, as such a change would require all subsequent blocks to be recalculated. Furthermore, it is difficult for a user or group of users to monopolize the computing power of the network, as the machines and the power required to complete the hash functions are very expensive. And in order for him to manipulate billions have been spent, and it's simply not worth it. In principle, proof of work is a mechanism that delays the creation of blocks. In the case of Bitcoin in particular, it takes 10 minutes to calculate the necessary proof of work and add a new block to the chain. This mechanism makes it almost impossible to change a block successfully, because all the proof of work of subsequent blocks must be recalculated. From hashing and proof of work comes the technical security of blockchain. When we talk about the ledger, again, a little bit historical approach to the ledger. In order to be able to explain how the blockchain is protected in the last third way, it is necessary to understand exactly what a ledger is and how it contributes to security of the blockchain. What exactly is a ledger, actually? A ledger is a database that contains information about transactions, debits and credits. Imagine that your bank statement is a ledger. A balance sheet is a ledger. Basically, ledgers have existed from thousands of years ago. And the first ledgers was being applied to stone, then to clay tablets and papyrus, then in some blocks, then the paper come after, and finally we go to the books that support bookkeepings, and as we know it today. And these ledgers help to create money, to trade, to credit, and help for the evolution of banking. Over the last few centuries, however, the ledger moved into the digital age. And basically replacing room full of accountants with computers, and thus the modern global economic system was gradually born. This accountability is being revolutionized again as ledger issues move to connected global network of computers that is cryptographically secure, fast, and decentralized. And decentralized is the key word when we explain the blockchain. And we call this network as distributed ledger. And what exactly is a distributed ledger? It can be explained as a ledger whose transactions are supported by a decentralized network of different locations, computers and people. And this eliminating the need of a central authority. If we make some kind of comparing, the bank in the previous and in nowadays, of course, the bank is the institution that guarantees the transactions and guarantees all the and keep all the trust of the people. That's why people use bank to send money and to trade. And if we put the blockchain technology and this distributed ledger, it will be not necessary to have central authority like the banks. And this could be explained why the banks are so not not happy with the blockchain technology. This ledger contains all the and to continue. This ledger contains all Bitcoin transactions arranged in consecutive blocks so that no user can spend the same amount more than once, and thus to creating trust in the ledger, and its users can trust it 100%. How does the shared ledger work in crypto world? All information on the ledger is uploaded and protected by cryptography and can be used after being unlocked with cryptographic equation keys. Any changes and additions to the ledger are transmitted to all participants in seconds. All participants can access the ledger at any time and can hold an identical copy. The copy starts from the generic block, contains information about each transaction, blocks, and so on and so on. And the copy of the ledger of the date is just over 150 gigabytes. When we're talking about distributed ledger, these ledgers can be used to record, track, monitor, and exchange any form of assets. All assets register inventories and exchange involving every part of the economy, finance, and currencies. physical assets such as cars and houses, intangible assets such as votes in elections, ideas, coppers, information, and so on. In this case, blockchain can serve as a depository of public record for entire societies, including registration documents, events, personal data, and assets. In this system, anything can become a smart thing. This concept of encoding each asset on the blockchain with a unique identifier allows the assets to be tracked and controlled and exchanged in the chain. For example, distributed ledger can be used to replace or complement any existing intellectual property management systems, as they can record the exact content of any digital asset, such as file, image, health record, or code in the ledger, and give it unique identifier in the form of the hash values. There is two types of distributed ledgers. One is public and one is permissioned, so it's private. Public is open to everyone. For example, Bitcoin operates on such a ledger. Anyone can open it and read from the chain. Anyone can allow changes, and anyone can write a new block to the chain. At the opposite, for example, Ripple is a good example of that, of a closed ledger, where only with permission of the creators it will be possible to operate it. Ripple, if you're not familiar, is a mobile app for bank transfers. It's created from one of the banks that allows to make transactions immediately, and is based on blockchain technology. One of the first products that banks try to fix this pressure coming from the blockchain technology. But let's continue with distributed ledger. Distributed ledgers in each category have their own unique characteristic. Some are made from specific applications and others for general use. For example, Corda allows in a closed loop different organizations to have access to the same information, of course, with certain levels of user access, which is the opposite of the public platform. When we're talking about DLT, disintermediation, as the name suggests, there is no need for third party and intermediary. In this way, network participants can insert a date directly into the shared database. There is simply no need for a third party anymore from an intermediary. Some programmer could create a DLT on a blockchain and derive a public-private cryptographic key to give people a secure place to hold their information on that particular ledger, effectively allowing users to own their own information and access it. This is very different from what we know today. For example, Google and Facebook search up not extract all the little information that we have behind while using the internet, and then use it to offer us target ads, for example, from which they actually create their own turnover. This leads to a huge imbalance of power into the society. Teams of scientists and mathematicians of centralized organizations use the collected mountain of information or big data to target us and induce us to buy certain products that are advertised for their advertisers. Data is really valuable assets and information in the information society, and it's crucial to addressing major social challenges. I think that we talked about this yesterday. Often this big data is used against the public in many ways. In a world of distributed ledgers, people can own their own databases on the blockchain to give to different organizations to use when needed. This fundamentally reversing the current dynamics. And that's why the blockchain technology is so important, and that's why there will be a strong oppositions against the blockchain technology. And if I say something that using the blockchain technology, the power should not become in the hand of people, and not the opposite, in the hand of several persons who can control it. And this in fact changed the status, and of course rise a lot of other issues like security and a lot of things, but this is not the theme of our discussion today. We're just trying to explain what is distributed ledger technology. This is the case when people own their own data in distributed ledger. They can trade directly peer-to-peer, as the case in Bitcoin. When you pay, for example, when you pay in a taxi with the driver card, you supposedly pay to him, but in reality, the database, which is owned by your bank, is debited and transferred to the database of the driver's bank or to the taxi company. In this respect, that data nowadays is not held by us, but by someone, central institution, that we depend on to keep it safe and not to use it against us. This adds to the power imbalance in society. With blockchain, this is not the case. Things are straightforward here. Distributed ledger technology will greatly improve transparency, reduce corruption, and increase security while reducing the overhead of auditing, accounting, and legal matters. Imagine what it means to have everything uploaded to the blockchain, digitally stamped and untouchable. Currently, a huge amount of data is hidden in the databases of various institutions and organizations to which there is no access. They cannot be fully used for their intended purposes, and in the worst case scenario, They are used for purposes other than those for which they should be used by corrupt persons from organizations. It is not necessary to give an example of our native state institutions. For this reason, there is all kinds of regulations, bureaucracies, and so on, to protect the data from malicious use, which brings additional administrative costs. Individually, these information services are not as secure as blockchain, and information can be stolen. Imagine hacking the Ministry of Interior or the National Security Agency. What will happen? And it is not efficient to constantly update the information. It is much easier to have it in one ledger, to which different institutions have a certain level of access. And this gives us a really good way to optimize the processes and reduce the threats and raise the security. If someone is interested, you can watch a video of actually how the blockchains works. It's on YouTube. Blockchain and cryptocurrencies. Blockchain and cryptocurrencies are two terms often used interchangeably. However, there is a big difference between the two. Cryptocurrencies are digital currencies that use blockchain as a ledger for storing records of crypto transactions. The blockchains have many uses beyond cryptocurrencies, including, I already mentioned that, storing, accessing medical data, supply chain, and so on. Most cryptocurrencies, of course, use blockchain technology to record transactions. For example, the Bitcoin network and the Ethereum network are both based on blockchain. What actually are cryptocurrencies? Cryptocurrencies are actually digital assets designed to work as a medium of exchange that uses cryptography to secure transactions, control the creation of additional units, and to verify the transfer of assets. Basically, the same as which the money we know. Bitcoin, created in 2009, I already mentioned that, was the first decentralized cryptocurrency. Since then, numerous other cryptos have been created, which are called altcoins, as a mixture of alternative coin. In reality, alternative coins are like substitutes for Bitcoins, each with their pros and cons. If I make it a joke, those who are not worth it have another nickname, but I will not mention it now because it's not for our audience. Of course, you can see all the currencies, cryptocurrencies. You can see it on CoinMarketCap, and of course there are several other sites that you can check all the currencies. What is the difference between coins and tokens? It is important to know that all coins or tokens are considered cryptocurrencies, even if most of coins do not function as a currently of a medium of exchange. The term cryptocurrency is a misnomer, as currency is technically a unit of account, value, and medium of exchange. All these characteristics of money are inherent in Bitcoin. And since the crypto space has been started since the creation of Bitcoin, all other coins Bitcoins are generally considered as a cryptocurrency, even though most of them do not fulfill the understanding of money. And do not fulfill the characteristics of actual currency. The most common categorization of cryptocurrencies are alternative crypto coins, tokens. A token is not a coin. It uses the technology of an existing coin, and it's kind of part of it. Similar to our currency board, let's say, if you can compare it with currency board in Bulgaria. It is important to know that when creating a new coin or token, an already existing algorithm is used. As we said earlier, there are about a dozen algorithms. The new coins is actually built using the original Bitcoin protocol, which is open source with slight changes to its underlying codes, and thus creating an entirely new coin with a different set of features. This is called a fork. It comes from a fork, the word for fork, and has the same history but a new future. Let's say the change of government is the same kind of fork. There is also a hard fork and soft fork. The hard fork has to be upgraded with the software, but not with the hardware. And when we're talking about crypto wallet, this is software program that stores your coins. More technically explained, this is a software program that stores your private and public keys. They came in pairs, allowing you to send and receive coins via the blockchain, as well as monitor your balance. And in practically, the Bitcoin wallet is exchange for paper. When the other characteristic of cryptocurrencies is anonymity. This is one of the strongest advantages of the cryptocurrency, at least at this stage. Yes, all the information is in the ledger, but it is numbered and letters. Rather, it is not even anonymous, but let's say pseudo-anonymous. There is no understanding. So this is why there is all this talk about how to collect taxes from people, prevent money laundering, and sponsoring terrorism. In reality, these are also the arguments of the centralized agents like government. With crypto, they just lose control. It should be noted that no matter how anonymous it is, to do anything in the crypto world, you go through such procedures that your information is in many places. And the state authorities recently forced the world's largest exchange to surrender around 15,000 accounts in Coinbase. When we talk about what is mining, and mining Bitcoin works as a peer-to-peer network. This means that everyone who uses Bitcoin is a small part of the Bitcoin bank. But where do Bitcoins come from? With paper money, the government decides when to print and distribute money. Bitcoin has no central government. Within Bitcoin, miners use special software to solve mathematical problems and are issued a certain number of Bitcoin in return. This provides a smart way to use currency and also creates incentive to more people to mine. And since miners are required to approve Bitcoin transactions, more miners mean a more security network. The Bitcoin networks automatically change the difficulty of math problems, depending on how quickly they are solved. In the early days, miners solved these problems with their personal computers' processors. Miners soon discovered that graphic cards used for gaming were much better suited for this kind of math. These graphic cards are faster, but they use more electricity and generate a lot of heat. The first commercial products for residential mining included chips that were reprogrammed for mining operations. These chips are faster, but increasingly hungry. ISICs are specifically designed for Bitcoin mining. ISIC's technology has made extracting the bull even faster while using less energy. As Bitcoin popularity increases, more miners join the network, which inevitably makes it harder for individual miners to solve the math problems. To overcome this, miners have developed a way to work together in pools. Pools of miners find solutions faster than individually, and each miner is rewarded in portion of the work he or she provides. Mining is an important and integral part of the Bitcoin that provides fairness while keeping the Bitcoin network stable and secure. A little about pools and hashes. One card hashes with one card hashes with about 30 for Ethereum, for example. So the one who hashes with about 67,000 cards, which depending on how many he bought. But let's say it depends on the price of the card. It could be made, or this person can make around 4 million per month. Of course, according to today, this calculation is probably not correct, because we constantly have a rising of the prices of these cards, and it is hard to catch up. There is two types of mining with ISIC chips and graphic cards. We already mentioned that. The Bitcoin technology is which works on the SHA-250 algorithm. They use graphic cards. In reality, when a block is mined, the miner sends the block all other miners on the network as proof that it has found it. This block contains a list of transactions, the discovered hash, the specific random number, and reference to the previous hash. As each miner receives the newly mined block, it removes any transactions currently being mined that exist in the blocks, because they have already been confirmed on the blockchain, and passes the block on to other miners who do the same. Reproduction happens quite quickly. Here we come back to blockchain info again. Each block pool, and etc. The difficulty here that the profit from mining depends on the current price of the coin being mined, and the difficulty of mining the coin itself. The more they get involved, the harder it gets. This in turn refuses a lot, and difficulty drops slightly while the volume of transactions increase, and so the system, the cycle continues. The next point are exchanges. The exchange of cryptocurrency is done through exchanges, just like with other tangible and intangible goods, such as gold, oil, and sugar. And there the price drops and rises, and players pay against each other. The principle is the same, with the one huge difference that standard exchanges are heavily regulated, while crypto exchanges are kind of like the Wild West, where manipulation is done by big exchange companies and players, simply because it is not illegal. There are no rules. Most exchanges accept money and exchange cryptocurrency according to a certain exchange rate. Others only accept cryptocurrency. And the problem is that the cryptocurrencies do not feel well with the idea of decentralized financial systems. Crypto exchange, not currency, sorry. They are liquidity problems. Crypto exchange represents only one potential point of infiltration, and thus become a target for hackers. The world's leading time exchange has been hacked, and 650,000 bitcoins was stolen. And after that, this crypto exchange declared bankruptcy. Another notable hack is on one of the most popular exchanges in the world. It's Bitflex, and it was stolen 120,000 Bitcoins. The problem is that the exchanges hold your private key and your funds are in an unsafe place. There is no certain central authority to recover stolen crypto, and users can complain to the big spaghetti monsters, if I can joke. There is a problem with clearing and settlement in transactions because crypto exists in an irregular space, and clearing and settlement cannot be done through traditional regulated channels, creating extremely high risk for exchange users. Also, the exchange is not ready to act as anything other than a third party that only arranges transactions between buyers and sellers. This means that they are not directly anticipating to every transaction that takes place, and thus bear the little responsibility for what happens in their platforms. They are centralized, they are not responsible, and they are and there are exchanges with turnover for several hundred million per year. The lack of technological capabilities is the other issue that this exchange face. Some of the exchanges do not use enough modern and good software, and there are often problems with their use. In order, for example, of work without fail, a lot of computing power and support teams are needed. And what actually is the future of this exchange? A lot of people are, some people are advocating to the creation of decentralized blockchain-based exchange with no central authority and where transactions are impartial in nature. Whether purely technically decentralized exchanges can be handled, the high volume of traders and situations where instant trade communication is required is another question entirely. However, decentralized exchanges would bring transparency to trading, mining. It would be meaning it would be nearly impossible to falsify transactions on blockchain-powered platforms. And here it's good to mention that do not forget that decentralized exchange also means that there isn't just one point of infiltration, which means that major hacks will be harder to pull off. And what is ICO? It means initial coin offering. In other words, a few fashion for raising capital. It's common to use to be with when we're talking about entrepreneurship, when we're talking about new ventures. Usually we use, and the standard way of financing these startups was through angel investors, traditional banks funding venture capitalists. And now most of them is through token sales before you even have a product. Actually, you are selling an idea. And this is a type of crowdfunding. And in the graphic, you can see how in time this creation of ICOs, or creation of new coins, was made. And you see how the cycle is going up and going down, and what actually is happening at the end. But if you want to invest, usually this ICO or additional coin offerings are used really for startups companies, and they are really risky. And of course, there could be a lot of risk. Similarities between blockchain and cryptocurrencies. Both blockchain and cryptocurrencies are intangible. Cryptocurrencies are intangible digital tokens which you cannot hold physically, like the US dollar or the Indian rupee. The blockchain used for storing cryptocurrencies do not exist in a single place or one physical data center. Advanced, both blockchain and cryptocurrencies are technological advancements. Blockchain is the underlying technology behind cryptocurrencies. Blockchain is much more advanced and secure than traditional databases, and cryptocurrencies are technologically advanced compared with physical and pre-based currencies. Interdependent. Blockchain came into existence to record transactions of Bitcoin, the world's first cryptocurrency. All major cryptocurrencies have blockchains for recording transactions, and if someone buys a new Bitcoin, it is recorded in a Bitcoin blockchain. Oops. Inherent nature. Blockchain is a storage technology used for saving data in decentralized networks. Cryptocurrency is a medium of exchange like the US dollar, and the blockchain can be used for storing different types of information beyond cryptocurrencies, transactions, and records. Monetary value. All cryptocurrencies have monetary value. You may have heard of Bitcoin hitting a high of $65,000 or either reach $4,000. A blockchain does not have any monetary value. This is important. Usage. Blockchain technology has uses beyond cryptocurrencies. Blockchain can be used for recording transactions in banking, healthcare, supply chain, and retail. Cryptocurrency is digital money, which can be used for buying goods and services and for investment. What is the differences between blockchain and cryptocurrency? Mobility. Blockchain technology is decentralized and distributed all over the world. There is no single location where all records of a blockchain are stored. Cryptocurrencies, although held blockchains, can be accessed via mobile wallets. And if you have a Bitcoin wallet, you can use it to anywhere for transacting with parties accepting Bitcoins. Transparency. Blockchain, being a public ledger, is highly transparent. Anyone can join the blockchain network and view the information available. On the other hand, cryptocurrencies offer anonymity. Anonymously. So while anyone can see the source, disintegration of a Bitcoin transaction, no one can know who is behind the transaction. And there is a question from the chat. Can a messaging application be written with blockchain technologies? I'm pretty sure that everything can be based on blockchain technologies. And yes, the answer is yes, it can be done on the blockchain technology. Basically, the whole idea is that everything can be put on blockchain technology. It's not now. It's more than to talk about cryptocurrencies because they're based on that technology. But that technology can be used in many ways. That technology can be used in every single part of our daily life, and in that case, this could be optimize a lot of expenditures that we make every day, and this will change in the core the way that we communicate and that we store data, and a lot of professions and what works actually will become unnecessary for the world, because this technology will guarantee. And in the other hand, there will be a lot of transparency, providing different services. So everything could be made by everything could be made based on technology of blockchain. And the fourth part is Internet of Things, edge computing. The Internet of Things is the interconnection of endpoints, devices, and things which can be uniquely addressed and identified with an IP, Internet Protocol addresses. With the Internet of Things, devices can be connected to the Internet, since gather, receive, and send data and communicate with each other and applications via IP technologies, platforms, and connectivity solutions. From connecting devices to human value. And you can see how it works, actually, the Internet of Things, from connection to benefit, starting with device connections and connectivity, continuing with data sensing and collecting, data transactions, the third parties, data transactions, and access. This includes big data analysis, artificial intelligence, and cognitive analysis in the edge. Continuing with data analysis, continuing with data value, defined by actions. This means anything analyzing to action, APIs, and processes actionable intelligence. And the sixth point is human value. This means smart application, stakeholders benefits, tangible benefits. What is edge computing? Edge computing is a network philosophy focused on bringing computing and as close to the source of data as possible in order to reduce latency of bandwidth use. In similar terms, edge computing means running fewer processes in the cloud and moving those processes to local places, such as on user's computer and moving these processes to local places, such as on a user computer and Internet of Things devices or edge server. Bringing computization to the network's edge minimize the amount of long-distance communication that has to happen between the client and the server. Edge computing and moving the intelligence to the edge. So what happens? We have a cloud and data centers, and there are thousands of them. And after that, if you see the pyramid, we have nodes, millions of nodes. We call it into the fog. And the edge is the final devices. There are billions. This includes machines, electronic devices, cars, medical equipment, whatever you came in mind can be put it into the edge computing and edge devices. And point 5, it's Industry 4. Now it's really modern to talk about Industry 4. It is a term for the fourth industrial revolution, the digitalization and automation of manufacturing, where we are in the midst of fundamental shifts in the way products are produced, and it's deeply tied to the future of the Internet of Things. Advanced in networking, machine learning, data analysis, robotic, 3D printing, and other technologies are making vast improvements on industrial processes and reducing our dependence on human labor and decision-making. By leaning into digital solutions, manufacturing can be reduced human error, shorten time to markets, and increase the speed of which industrial process can be adapted to new information. And this, of course, optimizes the expenditures. And of course, this raises a lot of social issues, because when human is replaced by machine, the biggest question is what is happening with the human and what these humans can do. One of the decisions is, but of course this is connected with education, is that it's really important to educate these people who till now are working on a machine like machines, to educate them more, to be more creative and to start works that are not standardized. If you take a look historical again on the industry 1 was the mechanization. from 1760 to 1840. And after that, the electricity shows up in 1870 to 1914. The electricity was the biggest boost to industry. And from 1940 to present days, the industry 3 is IT industry, which again changed the way of doing business and the way of the economics works. And now we're expecting industry 4 or Internet of Things for official beginning of this industry is 2015 to now. So we will see what will happen with these industries and how this industry 4 will develop and where it goes. Industry 4 is revolutionizing the way companies manufacture, improve, and distribute their products. Manufacturers are integrating new technologies, including Internet of Things, cloud computing, and analytics, and artificial intelligence and machine learning into their production facilities and through their operations. These smart factories are equipped with advanced sensors and software and robotics that collect and analyze data, and also for better decisions making. Even higher value is created when data from production operation is combined with operational data from ERP systems, supply chain, customer service, and other enterprise systems to create whole new levels of visibility and insights from previously siloed information. So Industry 4 includes cloud computing, data analysis, point of sale, smart buildings, smart vehicles, smart metering, robotics, directional integration, cyber security, and so on and so on. And the final point is robotics. Robotics is an interdisciplinary branch of computer science and emerging engineering. The field involves the design, construction, operation, and use of robots. Robots are more precise and efficient than humans. Medical and industrial errors can be almost eliminated with the use of robots. By using robots, businesses can see massive savings and cost-effective changes to jobs that may take humans days to complete. If you are interested about robotics in business, you can visit this sdnet.com and see this video about the robotics in business. Robotics are moving into the businesses world in a big way. There are already 2.7 million industrial robots in use in 2021, and the cost of the use of these machines is coming down, even in functionality goes up. New ideas like robots as a service, letting SMBs leverage the existing productivity boost robots can provide. Thanks to breakthroughs in robotics like News Sensor, Teach, and artificial intelligence, modern companies are seeing big jumps in productivity and earning power. And robots as a service, device business models of robots as a service. You can do it in several ways, like annual lease, monthly rental, hourly charge, or with minute usage, pay per task, factory, pay per pick, warehouse, pay per delivery, and percentage of grocery purchases. So this is the different business models based on robot as a service. And here is the websites that you can receive information all about all the topics that we discussed today. Thank you very much for your attention. I hope that this lecture was useful for you.
Hello again, everyone. We will continue our session with the presentation of EasyMath. Pavel is here, who is co-founder of EasyMath. And Pavel, floor is yours.
Thank you very much, and thank you for everyone who is going to be listening today. Now I'm going to share my screen to show you the presentation. What I want to do is first give you all a little background about our company and how we've grown over the past 3 years. And then I'm going to dive a bit deeper into our response to the COVID pandemic. And I'm going to try to leave some time at the end to answer your questions. Let's start. First, just a few words about myself. My name is Pavel. I am 19 years old, and I currently study computer science at Sofia University. I am the co-founder and course coordinator at EasyMath BG, which we actually started when I was still in high school. I had just finished 9th grade, I believe. But first, I want to give you a little bit of background about why we started this company. In short, competitive mathematics is really a big deal in Bulgaria because the number of children that participate in competitions is just really big compared to our population. And for example, on the International Mathematics Olympiad, often the Bulgarian team actually outperforms countries like Germany and Spain and Italy and so on. So a lot of time is invested by many people in this space. I myself have been a math competitor for many years, essentially my whole school career. But what I'm actually going to talk about today is my experience on the other side of things as a courses creator rather than the student, and also as an organizer of competitions rather than the competitor. In 2017, I was 14. That was before EasyMath was incorporated as a company. We did our first math competition with my problems. Here you can see a photo of me during that time, and with the children that have won. And it was really well received. People did like my problems, and essentially that was when I started thinking about how it actually makes more sense for people who have spent time as competitors to be in this field instead of the people who don't have experience in this. And a little more than a year later, in early 2019, which was before the pandemic, actually, my little brother, you can see him pictured right here, he was also trying to prepare for his actually math exam, but it's actually a competition because it's much more difficult than school math. For admission to a math school, which are also very popular in Bulgaria. And so I helped him. We spent quite a lot of time like solving problems and discussing them. And then I started thinking that I can actually try to transfer this experience to other children, not only to my brother. And so in summer 2019, we actually incorporated EasyMath BG, and I started creating the initial product, which was a online platform. It was designed to be used exclusively online from the beginning, from before the pandemic, and it was about self-learning competitive mathematics. Actually, the first part of the platform was a collection of video lessons, 64 video lessons covering all the competitive mathematics material for elementary school children. And I recorded them with just a basic laptop and microphone without any special equipment or without any prior experience in doing this. And obviously the sound quality was not great. Also the design was not great. but the very idea of those things being explained in a simple language that is close to that of children was very well received. So from the very beginning in 2019, we started getting a lot of positive feedback. That was just our initial product, this collection of 64 lessons, working on a subscription basis with yearly subscriptions. It was once again designed to help just children from 2nd to 4th grade. So it was a very narrow age range. You can see here is a number, more than 2,000 users. It's actually more at this point. This is the total number of paying subscribers to this initial platform to this day. It's now more than 2,000. That was our initial product, and we hope that it by itself was going to make us a successful company. But as it turned out, you have to constantly try to improve and come with new ideas. So obviously, we launched in fall 2019. So just less than half a year later, the pandemic started, and I'm going to dive deeper into that a bit later. So I'm going to skip that for now. Around the end of 2020, we received actually an award from the Bulgarian Chamber of Commerce and Industry, which is probably the reason why I'm here today. We were awarded second place for most successful innovative company because of the model that we had implemented of actually trying to reach all the children around Bulgaria. Once again, I'm going to dive deeper into that a little bit later. Also at that point in 2020, late 2020, but by this point, we started actually making our own competitions, not only the lessons, but online math competitions. They have been attended by more than 3,000 children at this point. And at this point, we make 4 competitions per year. And we also start making mock exams for 4th graders, which is actually the most serious grade for competitive mathematics, because essentially all the admission to math schools comes from math competitions after 4th grade. So we started doing that. You can see here a gallery of some of our winners. Those 2 pictures in the center, they're from actually the only award ceremony that we managed to do in person before the pandemic. All the others have been sent to us by the parents of the children, showing how happy and satisfied they are with their awards. Naturally, we decided to use those problems that we had created for the competitions, and we created our first printed problems collection, which was published in 2021. There's not much to say about it, other than it's a luxury hardcover edition. With the idea of, because our problems were initially made to be used online, they have a lot of colorful illustrations, and even some of them have moving animations. So we tried to make it as accessible on paper as it was online. They have QR codes with the motion, and we believe that this was the only way to actually make those problems solvable on paper. Not just a black and white small book. So that was it. Right around that time, already in 2021, we actually started our biggest sort of project to date, because while people were using our online platform regularly, many of them were asking about the possibility of real-time courses, and that's something that we actually implemented in 2021. And as you can see, we already have quite a large team of people who are teaching those courses. And we also believe that this is a very scalable product because each of those people that you see, they have recently, just like me, recently graduated from a math school. They have years upon years of experience in math competitions. And we do believe that this is actually the right kind of people to teach those topics. And obviously, every year there are many recent graduates of those math schools. So I don't think we'll ever run out of lecturers. We try to meet all the demand. In fact, our first school years, as I said, 2021 to 2022, we had, I believe, 18 groups with 12 children each on a weekly basis on these real-time courses. And for this year, this academic year that is now about to start, the 2020 to 2023, we already have nearly 35, I believe, groups with 12 children each. And our team is, as I said, constantly growing. We were just 8 people last academic year. And as you can see, we are now quite a lot more. We are trying to open new groups on demand as soon as we run out of available spots, and there is still children wanting to enroll. We try to accommodate that as much as possible. So that is a very, very quick overview of the history of our company. Of course, we have a lot of new things to do, and I'm going to save that for the end. And now I'm going to dive deeper into our response to COVID. Of course, as an online business, many people would say that COVID actually benefited us, but that's not entirely true. Definitely, it's not true for the first months of the pandemic. But if you all remember what the situation was since, let's say, March through August 2020, we were then still a very, very young company, less than a year old, less than half a year old, actually. What happened was that people were really, really scared of what was happening. And so they were very cautious about their spending. So especially during the first month, I believe March 2020, we have essentially no new orders. And those that were made recently were never paid, actually. And obviously, as a young startup, you do have recurring expenses like salaries and other expenses, which cannot just be paused that quickly. So we were essentially on the verge of giving up at this point, because it was literally a very, very hard month, maybe 2 months. So essentially no traffic to our website. And what we decided to do as a first response, as quickly as we could think of it, was to actually drastically lower our prices. Here I'm talking about like 80% discount, 70-80% discount. For two reasons. Obviously, we needed the cash flow, but at the same time, we wanted to actually help those people because their fears were reasonable. As it turned out, we are more than 2 years now into the pandemic. So we wanted to actually not deprive children of their education at this point, obviously as they were staying at home. So we made those really promotive prices. They were available for the better half of 2020, at least until the summer, and it did so quite some sales, but at the same time they were at a very discounted price. So that's all that. And we also, as I said, started thinking about new ways to make income and new products to offer. That would be, of course, our competitions and then the real-time courses. There is a question here. Can we find Turkish translations to your books and magazines? Not yet, unfortunately. They have not been translated. Okay. And so yes, that was our first response. And then we started thinking that we're in a pandemic, obviously, so we have to think digitally. By the way, I would say that the pandemic had one very profound positive impact, not only on our company, but industry-wide, because people started to realize that there are people outside of the big cities, because essentially up to 2019, there were real-time courses in only 3 or maybe 4 cities in Bulgaria altogether, which are like a third of the population or less. And so the vast majority actually of children never had access to that. That was one problem that we partially solved with our online platform, but we believe that we have now essentially offered the solution entirely for children from small towns to pursue our real-time courses, which are entirely online. So yeah, we started thinking about digital solutions. Our website was fully upgraded, which includes the website itself, the infrastructure, but at the same time, the content on that site. In 2020, the summer of 2020, I re-recorded every single video essentially, with the help of better equipment, obviously, and also a professional designer, this guy, Vesco. So what we did was actually offer a product that was great quality in terms of technology, not only in terms of the teaching methods. We also integrated the ePay system, which allows customers to pay with card, not only with a bank transfer. And we also launched that's unrelated to Easymat, to this presentation, so I'm just going to mention it. We launched the Kiosu platform, which essentially allows you to have those competitions online. And that's a platform that we've used for that. As I said, it's a different company than Easymat. And we also drastically increased our online advertising budget. Obviously, part of that increase was to cover up for inflation, but at the same time, we also increased it above that, because we realized that actually people need to hear about our products. And as I said, our biggest project today was the real-time online courses that we started, which began in 2021. We used quite a bit of digital tools, as I said, the Kiosu platform, the ePay system, the Zoom platform for our online meetings in the real-time courses, and also the Facebook and Google Ads. So those are 2 main advertising channels, but we also advertise on other places, but Facebook especially is really effective in this. As I said, it was really a lot of work to do over those years. And I'm really happy to say that we have, at this point, become a household name in the math community, in the sense that people know that we are offering what we are offering. And that's especially helpful, once again, for people in small towns and rural areas, because they traditionally lacked any access to this kind of education. We've received nearly 100% positive feedback from children, parents, and teachers alike. We have had the teachers use our platform at school. We have, as I said, that 1,200 is also an outdated number. It's more than 2,000 at this point paying subscribers for the platform. More than 1,000 printed problem collections sold. Around 700 children have attended our weekly real-time courses, which are online once again. And more than 2,000 children have participated in our competitions and mock exams. That number is likely to go much higher in this school year. And of course, I want to briefly talk about our future plans. As I said at the beginning, our online platform was essentially created for children from 2nd to 4th grade. So we wanted to expand into other age groups. And the good thing is that you can expand both below that age group and above it. As for younger children, you obviously need much more specific methods to teach them. our real-time courses do include first grade, who are 6 to 7 years old. So they're really small children. And we do plan to start maybe kindergarten level. It is again going to require some preparation. And we also want to expand, as I said, to older children. We have actually already done that in our online courses. They do cover 5th, 6th, and 7th grade. For example, 7th grade does include the national external evaluation, which is the biggest exam essentially in Bulgaria, which every 7th grader is required to take. That's maybe 60,000 children a year, and all of them take it, not only those that want to compete. So that is quite a large market that we want to serve. Once again, in every corner of Bulgaria. And actually, not only in Bulgaria, we have had many children who are of the Bulgarian diaspora, many from Germany, from the UK. We actually had one from Japan. It was quite funny with the time zones, but we had one child from Japan. Another goal that we have for the future is, of course, to further expand our wonderful team. As I said, we only count on people who are very young. As I said, I'm 19 years old, and I'm maybe around the mid-age for our team. We've had people maybe from 17 to 21, and just actually that person, Vesco, who made the design, he's maybe 25 at this point. But the average age is definitely below 20. And as I said, there is a constant stream of more young people of these ages graduating from math high schools who have years of experience in competitions and who are definitely willing to help with our cause. And another goal that we have for the future is to work with public schools and other educational institutions to promote not only our platform, obviously, but also to promote mathematics in general and critical thinking in general, because math skills are absolutely essential for living in the 21st century, and generally math is everywhere. So we do believe that there are a lot of things that need to be done in the Bulgarian system in that matter, because as I said, there are a lot of talented competitors that frequently outperform the teams from Germany and Spain. But at the same time, maybe the average Bulgarian child is not too much into mathematics. So there is some sort of a bell curve that's not very pleasant. So that is something that we want to work on. As I said, I wanted to have maybe 15 minutes for questions, so we do have some time left. So I plan to actually open our website to show it to you. Just a second. So this is actually our website. Let's hope it loads. Okay. The internet is quite used by the Zoom call. So this is our front page. As I said, it was completely redesigned in 2020 to be as user-friendly as possible. Obviously, the text is in Bulgarian, so I'm going to maybe look at the overall design, not that much on the text. So here it says math is easy with EasyMath PG, which is one of our main models to actually make those ideas simple and understandable to young children. And actually, here we can go to our online platform. As you can see, it is currently in 2 modules, not only the initial one. The first module is video lessons, which is actually the one that I've worked the most on before our real-time courses. And as you can see here, we have already there more than 40 lessons with two videos each, so more than 80 video lessons at this point. And it covers all the material on competitive mathematics. It is structured, intentionally it's structured by stars of difficulty from 1 to 5 stars, not by grades, because we do believe that, for example, people from children from like 2nd grade, some of them are better than other children from 4th grade. So it only makes sense to structure them by difficulty, not by age. So that is our first module of the online platform. And here is our second module, which is actually very, we have some filter. Yeah, I removed the filter. We have, as you can see here, 341 different competitions, more than 5,000 problems, individual problems. And this is essentially the largest database in Bulgaria of all the previous problems that have been given on math competitions. Obviously, some of them are created by us, our problems, others are from other competitions. But what's uniquely for this module is that we have provided a comprehensive solution to each and every one of those problems. So more than 5,000 comprehensive solutions, which are our creation. They're not available anywhere else. And so those are the two modules of our online platform. The other thing that I mentioned was our competitions. As you can see, we have an advertisement for our next competition. It is going to be on 8th and 9th of October. And once again, it is 100% online. So it is accessible to children from every corner of Bulgaria. And last but not least, you can see actually our announcement for the real-time courses. And here, obviously not that. Our announcement for the real-time courses, here it is. This is for the 2022-23 school year. And as you can see, we have about 35 different groups. And those that are in red, they are filled up at this point. Those that are not in red still have available spots. But we still do have time before we start. We start in early October. So that's it. And last but not least, I want to show you this here, which is just a second. Yes, our team. Here is again each of our contributors. This is me, and this is Sasha. We are the creators of the online platform. I have created around, as I said, 64 videos. She has created the rest. And each of those people below are actually lecturers at our real-time courses. And just to gain a perspective, everybody from here on, so from this girl down to here, all of them are our recent additions to our team since the last maybe 5 months. So those above them are from before that. So to conclude, I would say that mathematics is once again a very important thing, obviously, and it is even more important to start teaching it in a good way from a young age, because we see people who are essentially graduating high school and after that they don't have any fundamental knowledge of mathematics. So that is very bad. I mean, they can't really participate in a digital economy in today's world. And the way to do that is really to be as inclusive as possible, in the sense of not, for example, discriminating based on the region of the country that you are born. A fun fact is that one of our lecturers, he was born in a village of, I believe, 100 people. This person, Georgi. He was born in a village of 100 people. He then moved to the provincial capital in 4th grade and then to Sofia in 7th grade to study where I studied. And then he's now in the Netherlands pursuing his higher education and also still teaching with us. And the sense is that we want to make that like a commonplace for people to be able to study math and to be successful in competitions from every corner of the world, of the country for now. So yeah, that's generally my presentation. As you can see, we have my contacts on the screen, and I will be very happy to take your questions in the remaining time.
Thank you, Pavel, for your valuable presentation and interesting presentation as well. And if we have questions from the participants, we'll be happy to have it right now. Any questions? I think there is no question, but we will have also your presentation and we would like to publish it also through our project website, and your contact information will be there as well. So if any participant would like to ask a question in future time, maybe they can reach you through your contact details.
Yes, of course.
And I think it's over. There's no question. Okay, then. Thank you very much for your participation.
Thank you very much for your time.
Today's agenda is over. Tomorrow we will continue with our sixth and final module. And see you tomorrow at 11 a.m.
Thank you very much once again. Have a nice day.
Bye-bye.